Hello class. So we're going to do another ACE question today. I'll do one as kind of a walkthrough, and then you're going to have one on your own. Okay, so going to be using this formula for volume. So it's a volume of revolution today, and then your question is going to involve volumes of revolution. Okay, so that's from the other day. Where are we at? Right here. Okay, so we have this graph. So given that the volume obtained when the shaded region is rotated 360 degrees is 24 pi, find the value of A. Okay, so they're giving us the volume. So normally we use that equation to find the volume. We integrate the curve to get the volume. Where now they're giving us the volume, they're kind of giving us the curve, but we need to find a missing piece of the curve. Okay, so in that case, you're just basically going to use the volume at the very end to solve for A. But you still solve this like normal. Okay, anytime it's a volume of revolution problem, it's the same process. You integrate the curve, given the limits that they give you. Just at the end, we have to do, instead of solving for the volume, we'll plug the volume in and solve for A. Okay, hopefully that makes sense. If not, you'll see how it's going to work out. Let me find another sheet of paper here. Okay, so we need to know. We need the limits to the volume, 24 pi, limits are 1 and 3, and y is equal to A over x. Okay, so we want to find the volume. Or we know we're given the volume, but we want to find A. But in order to be able to use the volume, we need to come up with the expression for the volume. So that's from 1 to 3, pi y squared dx. Here the pi is a constant, remember, so you can just push it out front. Remember, when you're taking derivatives or integration, you're only doing it on the variables. So any constants, they just kind of hang out up front until you're done with the derivative or the integration. All right, y squared, so that's A over x, we're squaring that. So that's just A squared over x squared. X. Okay? Or you could rewrite it as A squared x negative 2 dx. Okay, A squared is just a constant as well. Remember, so dx means we're taking the derivative with respect to x. It means A, whether it's a constant or not, we don't care about it because we're not doing integration with respect to that. So the A just kind of hangs out up front for now also. Okay, so what's the integration of negative 2? So you add 1, so it makes it a negative 1, and then we divide by that. Okay, so we get pi A squared, and then the integration of this, so that's x to negative 1 over negative 1, evaluated from 1 to 3. Now this negative 1 underneath just means all this is multiplied by that negative 1. So I can just move the negative out front, like that. Okay, or you can write it without the negative exponent, like that. Okay, and it's still evaluated from 1 to 3. You guys know we evaluate it, plug in 3, plug in 1, so we get negative pi A squared over 3. So just plug in 3 to there, minus, plug in 1 to there. Negative pi A squared over 1. Now the double negative, so it makes that a positive. So same numerator, different denominator. So in order to add fractions, you have to have a common denominator. So obviously 1 and 3 is going to be 3. So this stays the same, I just multiply this by 3 and put it over 3. So basically this is 3 pi A squared over 3. And then negative pi A squared over 3 plus 3 pi squared over 3 is 2 pi A squared over 3. Okay, so we get that. So what do we do with this? Well, this is the volume. Volume is equal to, after we do all the work, we get that. So we get V is equal to that. So that is the V. But we're also given a value for, that was wrong, wasn't it? That should be 24 pi. Okay, So this is the expression for the volume, but the actual value for the volume is 24 pi. So that means these two things are equal to each other. So that's the only difference for this question, is at the very end we just use what we, instead of stopping here like we normally would, we are given a value for the volume. So we set it equal to the expression we got for volume, and we solve for A, and you get A is equal to 6. Okay? It was quite a bit of work. It's tedious. Integration for volume revolution and evaluating can get kind of tedious. But just keep checking your math after each step, and you shouldn't make any big mistakes on these. Okay, so here's your question for today, and I'll give you kind of a little walkthrough hint for it. So this one is due Thursday, so I'm giving you an extra day to do it, because you might need to go back and review the previous topic a little bit. So we have this curve and we have this line. Now what's the first thing you notice that's different about this? The line's actually on top and the curve is underneath the line. Normally it's the line and then the curve cuts through it. So when it's like that, so like the question y'all did the other day, you have the curve and then the line. So it's always integration of the curve minus integration of the line. Well, this one's just going to be different. It's the integration of the line, so it's the area under the line but cut off by the curve. Hopefully you understand that. So it's the integration of the curve minus the integration of the line. Okay, it's just like what we've done before, but instead of this minus this one, now it's this one minus this one. So whichever one's on top minus whichever one's on the bottom or underneath. Okay, they tell us a few things here. M is a minimum point, and A and B are the intersections. So part I is find the coordinates of A, B, and M. So find the x, y values of those. So A and B is kind of self-explanatory. They're intersections, so you should know how to find intersections by now. M is where you might need to review the previous topic. So minimum point, which is another word for stationary point. So basically you just find the stationary point of this graph and you will have found the M coordinate, the coordinates for M. Okay, so that's I. So a little bit of coordinate geometry with intersections, a little bit of derivative stationary points there. And then double I is the volume. So once you find A and B, so basically you found your limits, then just find the volume obtained when you rotate that about the x-axis. Okay? If you have any questions, just message me on Teams and I'll help you as best as I can. But other than that, it's due Thursday. If you get it done early, that's fine, but don't turn it in until Thursday because there won't be a slot for the grade for today. So you have to turn it in tomorrow. That way I can give you a grade for it. Alright, thanks guys. Have a good day.